Hello and welcome to Lesson 3 on Intro to Object-Oriented Programming. Today we'll be going over the structure of a Java program, explaining all the different confusing elements when it comes to object-oriented programming. We'll be using Eclipse and setting up our first project, so let's get started. Alright, so let's just jump right into Eclipse and start by creating our Java project. My Eclipse might look a little different than yours. I have just the package explorer here and the console down at the bottom, and usually to read the console I'll go ahead and pull this up, look at the console, pull it back down. I like to have as much code readability and space as I can. Sometimes I will drag two class files and have them separate so I can have two open at the same time. But you can go ahead and configure it to your liking. If you go to Window and you go to Show View, you can also pull up all the different views. So if you're into that, you can customize it however you like. But for what we're doing right now, we just got to right click in the package explorer, go to New, go to Java Project, and we got to give our project a name. So I'm going to call this Java Tutorial. I don't know why I put two spaces in there, but alright. So within this Java Tutorial package we've created, well, the project folder we've created, we have this source folder with the icon having a little tiny package in there, and then we have the reference to the system library. Now within here we need to add packages. You don't have to, but it's not best to use the default package, meaning just putting your source code in the source folder. It's good to have some organization in there. So what we'll do is we'll go to New Java Package up here. This is going to be within the source folder, and we'll give it a name. Now what we can do is we will type main, which is the main package, and then we'll put a dot, which basically we're making our subfolders here. So main is a single package, and then within main we'll add another package called lesson 3. So main.lesson3. Now what we can do is we can create a new class, and a new class is of course a .java file, source code, and we can choose to either put it in main, like so, or we can go ahead and put it in .lesson3. Essentially, it's just a folder to keep classes separate and keep them organized. So for all the code that's going to be going to lesson 3, it's going to go inside this package. So main.lesson3 for the package, and we will name this, let's do animal. So now we have our first Java class here in Eclipse. So the package is main.lesson3. If the package were to be main, it would be sitting inside another folder called main. But since the only package we have populated right now is this main.lesson3, well, it's technically lesson 3. Let me show you to save confusion here. I'm starting to confuse myself. So essentially, my Eclipse workspace is right here. We have Java Tutorial. Then we have this src folder that you see right here. Then we have main. Within main, there can be classes. We can put source code in main here. But we have, in lesson 3, our Java file animal. So it's just another way of keeping organized. It's actually not that hard to understand. It's just weird. So essentially, we gotta change this back to .lesson3 because apparently it is not. So it basically, the program looks to see where it's at in the hierarchy of things, and it's throwing me an error because the class is not sitting there. If I physically move that class over into main, this would be fine, but this is not the package that it expects. Packages are not a big deal about learning though. So the first thing we have here is public class animal. Just like in the second tutorial, that is the name of our Java class here. So that's the name of our object. So we're going to create an animal object. And this is kind of the classic way of teaching here. Now in object-oriented programming, what we have created now is an object called animal. What we need to do is we need to give this animal properties. So Let's do it this way. We'll do an integer, which is int, and we'll call it legs. And it's that simple. Simply creating a new integer within the program is as simple as just typing int legs. But what if we wanted to give it a value? We'd simply assign it a value using equals. The equal sign is the assignment symbol. So don't think of it as equals. Equals is actually two of them, but I'll get into that in a later lesson. So essentially, using the equal sign is assigning a value to legs. So if I were to use equals 8, legs is now equal to 8. But that's not where we're heading with this. So we have our integer legs. Next, we need our integer... Actually, let's switch it up. Let's do a string, which is a string of characters, and we'll do name. So we'll have a string that covers the name of the animal, an integer for how many legs the animal has, and let's do a true or false value, a Boolean value, and we'll call it is mammal. Now, a quick thing to get into is naming conventions here. Before we get ahead of ourselves. So essentially, anything to do with a class name, is always a capital letter and then the name. And if it were to be two words, they will be next to each other. You do not use spaces in your variables. So if this was going to be public class animal apples, you would type it like that. Capital A, no space, capital A. Class names are always spaces for every word. For variable names are all lowercase, but if you are to use a second word in your variable name, the second word is capitalized. So we have name, we have legs, and then we have is mammal. Now you have to understand this is a true or false value. So when this is given a value and initialized and assigned a true or false value, it's either going to it's gonna make sense, because in that case you can ask yourself, is mammal? So if we use, say, an if statement when we learn those, it'll say if is mammal, then do this code. So essentially, using is for your booleans is very good. A lot of methods use boolean values like that with the is in there. But for the sake of this, we'll just use mammal. Now, what we're going to do next here is we have our three different types here. We're going to do some setters, okay? So what this program is gonna do right now, if this program were to be run, it would essentially make space in memory for a string, an integer, and a true/false value called a boolean. So that's really not doing anything. This program would run these 3 lines of code and be done. Oops, that's it. So what we need to do is we need to add some methods in here. Now what methods are is they're sections of code that can be called to run at any time during the program. So instead of it being like interpreted programming, which is like scripting, where it runs a line of code, runs a line of code, runs a line of code, it'll be able to just quickly hop in and run that code and then hop out. It's one of the key things in object-oriented programming, where it's all about the objects and running the code in series based on the culmination of objects rather than just the lines of code in order. An easy way to show you that before I go off on a tangent would be to open up idle. Now this is the Python programming language. If it'll launch, there we go. Don't worry about my font. My font is huge for some reason. It's probably from testing with the Raspberry Pi. But so essentially this is Python. Now in Python, it's an interpreted language, so each line that we enter is entered into the program and it's run as a script in just a straight line. It does have object-oriented elements, but Python is known to be a scripting language for, of course, Python scripts. So if we say x equals 3, and then we do x, actually, let's do y equals 3. Then we'll do, how about print x? Actually, yeah, that works. Print x. What am I doing? let's redo this program here. Let's do x equals 4, y equals 5, n equals x plus y, and then we're going to print n equals 9. I don't know why what I was doing at first, but essentially it takes each line of code and performs it in row like that. So we can essentially, with object-oriented programming, break that chain there. So what we're going to do is we're going to create a method. So we're going to call this a public method here. Public and private essentially mean what can access the program. If it's public, any program, any code that calls upon it is allowed to use what's in there. These variables that I have out here just floating inside the class, not within a method here, they are called field variables, and most of the time it's good convention to actually stick public or private onto them because they are field variables. Now within methods, it's not necessary to put this. That's why I didn't put them in the first place, because I'm not going to have another program that accesses this just yet. So I'll take that off for now. Now, we're going to create a public void. A void means that this method does not have to return any object. I'll go more into detail into that, but for now just know that a void is essentially just a chunk of code that is run. It doesn't have to give anything back to you. I'll be able to clarify it towards the end of this video, but so we're going to do a public void set name. Now what we want to do is we want to set the name of the animal. So we'll do a string, because that's what we're working with. We're working with a string. We'll call it name. Now you might think we already have a variable called name. Why would we put string name in here? Essentially, there is a really good way to note it, like to tell the computer what we're talking about. So what we'll do is we will say this dot name, which means the name that is a part of this class, not the name that is just sitting in this method. Think of it this way. If I were to do int x equals 3 in here, it says to me the value of the local variable x is not used. The variables inside here are local, including this variable inside the parameters is local to this right here. Anything outside of it cannot access it. That's why you use field variables, and that's why they have this blue highlighting, because they are variables that can be accessed by any part outside, like within this program, like within this animal class here, it can be used. So what we're going to do is we're going to say this dot, and we're going to say name. So the name within this class, so essentially the field name, equals name. So now we've taken the name that is passed into the parameter and made it equal to, we made this basically the name for the animal itself is now the name that we passed in through here. And we're going to do the same thing for the other two. So we'll do a public void set and we'll do legs next, so set legs. And now your method names have the same kind of naming convention as your variables. Set is the first word and it's all lowercase. There's no spaces, do not use spaces. And the next word is capitalized and name. So set name is the name of our method here. The next method we're going to make is set legs. So in set legs, we're going to need to pass an int legs. Now, what I should be doing is differentiating between the different ways you can do this, because this dot name might be kind of confusing, but it'll save you so much typing and so much confusion once you really get the hang of it. So I think for the Boolean, I'll show you the kind of newbie way to do it. But so we'll do this dot legs equals legs. So think of it this way: the new legs, like the number of legs, is going to be what we pass into here, and the legs for the animal, which is this class, is going to be what is passed into it. So public void set mammal. Let me see if this is going to make sense here. So set mammal. So this is going to do a Boolean, and what we're going to do is we're going to type new mammal. Now it's kind of confusing with a Boolean because Booleans are kind of different because you think of them as a true or false. Now, essentially, how we're gonna use our logic here is we're gonna say set mammal, meaning if it is a mammal, we're gonna say true. If not, we will say false. A better word for this, and now what I'm trying to explain to you is setters and getters, but the better word for this is, because it's kind of like you're asking the question and putting the answer in the parameters. So we'll keep this as mammal. But now we have this Boolean new mammal. So there's no need to use this because they're two separate variables. Even though this variable right here is local to this method, we can just essentially assign it to. So mammal equals new mammal, just like that. Now, if you've been following along and you have it all set up as is, we should be good to go. Essentially what we're going to do here is we're going to do some getters. So the next thing is to have it get the information. So we want the program to be able to give us this information when we ask for it. So the next thing to do is a getter. Now a getter is not a void because it is going to give us back the information we want. So this is going to be a public string, and it's going to be get name. And we do not need parameters because we're asking this class animal to give us data. So the next step is to just do it's a keyword called return. Whenever you have something that is not void like this, a method that's not void, it requires you, as it'll say right here, this method must return a result type of string. So essentially we've created a little string object that we need to give back to whoever uses this. So return, I can spell return, and we will return name. So whoever calls this method and is asking for the name of the animal, they will get the name of the animal. We got to do the same thing for the other two. So a public int get legs, return legs. Now this is all just showing you the structure of object-oriented programming. The next thing we're going to do is get more in depth into it. But the next thing is Boolean, if I can type it, Boolean get mammal. Now you might want to get more descriptive. Now you see how get mammal is kind of vague, like get mammal, like what do you mean? So you might want to say get mammal type, or again, you can find the compromise in saying set mammal. So you're setting if it's a mammal or not, and you can say Public boolean is mammal. So it's more of asking a question. It's all up to your preference, honestly. It's going to be you that's writing the code and you that's reading the code. I mean, unless you're working for a company. So it is best to just follow your heart with it. But we'll do is mammal, and we will return mammal. So true or false is going to be returned back. Now this is where it all comes together here. Now before we go ahead and make our next class here, I'm going to show you something very useful to keep organized, and those are comments. Comments are either a double backslash, and then you can type, or a backslash and a trisk, and then another asterisk and a backslash. And that makes a expandable section where you can just type whatever you want. It's good for leaving little notes, so I always use the double backslash and leave a little note. So this is going to be, we'll call this data fields, or the data field. We'll use an S, why not data fields? So these are going to be our three pieces of data. Below that are the setters, and below those three setters are the three getters. Now, good practice is to go in and while you're still, learning is to go ahead and comment everything you write. I mean, I even still do to this day, is to comment and make sure you're organized. If you don't quite understand, I mean, in this case it's very simple and repetitive, but if you don't quite understand what it's doing, always make sure you write it down. So when you come back, you'll have a better understanding and you'll be like, what in the world did I write? So the next step here, now that we've commented out and we know that we have our data fields here, our setters and our getters, you're thinking, what is the point in these 35 lines of code? Like, what are we doing? What we are doing is we're setting ourselves up for a really, they call it inheritance, and it's one of the best things in Java programming, and you'll use it a lot. We're going to create a new class, and we're going to call this class fish. Now to create a new class, if you didn't see, I click you click this C with a plus right here to create a new class, and make sure that it's in the same package as your animal. Now we're going to finish this class, and we now have public class fish. Now what in the world are we going to do with fish? Well, fish is going to use our animal class here. So let's go ahead and extend. So fish extends animal. So fish is a part of animal. So by extending animal, fish has now gained all of this goodness that we just added in here. So let me show you. So in this fish, what we want to do is we want to set up something to kind of figure out what we're working with here. So let's do public fish. Like public fish, there's no void, there's no int string. What kind of method is this? This is called a constructor. The constructor is a piece of code that is always run when this is made. So when we create a fish object, this code is going to run, and it'll make more sense as we get into this. But essentially, you use public or private, and you will write the name of the class. You'll have parameters, and then you'll have closing brackets. And you can use parameters, and we'll get into that. That's more in depth. But for now, actually, you know what? We'll use parameters for this. So we have our public fish, and we're going to include a string name, a int legs, and a boolean mammal. Now what we're going to do is we're going to store this data. So when we create this fish object with this data sent in, we want to save it. So what we'll do is we'll say this dot, and then we're going to go down and we're going to say set name. Eclipse already puts it in for you. It knows that you want to take this name right here and set that as the name. Then we're going to do it again for legs. This dot legs, and we'll throw legs in there. So basically it's passing it down the hierarchy of everything. So it'll all come together in a second. Trust me, my way of teaching is very weird. I don't even know why I'm doing these tutorials, but it'll all make sense. And we'll say set mammal. Now here's the thing, it says new mammal. And the whole reason it says new mammal is because that is the parameter it's asking for. It's asking you to give it a boolean. So we have a boolean right here in these parameters, in our hierarchy of parameters. So what we'll do is, we'll go ahead and give it mammal right here. Whatever it is, true or false, it's all algebra here. Whatever mammal is, it's going to send it in. For some reason, legs is undefined. Oh yeah, it's set legs. What am I doing? Okay, so our constructor's done. So what this will do, whenever we create a fish object, all right, we'll be able to save. Basically, it'll save everything we type. It's gonna make more sense when I make the last class in this one. But essentially, we're gonna make a public void because we need this fish to do something here. And what we're going to call this void here is we're going to call it print data. So print data. What we're going to do is it's going to print 3 lines here. So we're going to use our system.out.println, and we are going to use our getters here. Now println can print Boolean values, it can print string values, it can print int values, it can print it to the console and tell you what the value is. So all we simply have to do is use our getters. So we gotta say this.get legs. Well, let's do it in the order. Get name. Now the cool thing is that I use this just for organization. Because when you're reading all these lines of code and you're like, what is this set name method? Like, where does it come from? You actually don't need to use this if you prefer. It's good practice though. But essentially I can just do this dot, I don't need a dot. I can do get legs. Because that method, like I said, is inherited because the fish is a part of the animal now. So these methods right here are now a part of this fish. So the next thing we need to do is system.out.println. I hope I'm not confusing you guys too much with all this, but is mammal is the next one. And like in here, is mammal is going to return us whether it's mammal or not. It's going to say true or false. So is mammal. Now, we have our public void print data here. We have our constructor that creates the data for the fish. Let's go ahead and quickly make another one. Let's make a bear. So bear also needs to extend animal. So now bear extends. Now bear inherits everything in this animal class here. The data fields for name, legs, and mammal, our setters and our getters for setting the information and receiving the information. And now we can go ahead and say public bear. Let's add our parameters so we can give it the data on the fly when we create the object. So we'll do our string name, our int legs, and our boolean mammal. So the next step, just like the fish before, is to go ahead and say this.setName, name, this.setLegs, legs, and this.setMammal, mammal, not new mammal. Make sure, because it will tell you this error that there is no such thing as new mammal. It's just the parameter that we set right here. So we'll go ahead and change this to mammal because we have our object mammal right here in the parameters. Now, Next thing we gotta do is our public void print data, and we're gonna go ahead and do the same thing we did on fish. We're gonna print out exactly what we set when we created this object. So we're gonna do this. Oh, sorry, getting ahead of myself. System.out.println this .getName, and then another system.out.println this .getLegs, and then yet another system.out.println this .isMammal. I forgot my T's. Okay, now this is going to be very rudimentary, but you'll understand in a second. Let's create one more class. So this class is we're going to call this output. This class is what we're going to hold our main method in. So public class output. So we need to add our main method, which is the code that's going to run when we run the program. Our public static void main with a string array, the regular brackets, the right angle brackets, and we got to give it the name args, which is the launch configuration. Now, with it exactly like this, the program knows that this is the main method and the code that runs first. Now, essentially, we're going to do similar to an interpreted language. We're just going to go ahead and write the code in a straight line. So instead of adding fields and stuff, within this method, we are going to go ahead and create our objects. So what we're going to do is we're going to say fish in lowercase. So we're using the class fish, and we're creating an object of it called fish. Better yet, let's say clown. That makes more sense. So we have fish, clown. Now, fish clown needs to be, we have to assign it something, because if I just put the closed parentheses, the colon to end this, it says it's not used. And not only that, but it's equal to null. It has no assignment. So we need to make it equal to a new. So we're going to create a new object, fish. So we're going to make a new fish. So it's not that simple. We have the fish class here with our fish data, or well, basically we have our fish constructor that creates the fish, and then we have our print data method that prints out the data for the fish. But it says there's an error. And the problem with that is that this constructor is undefined. We have to add our parameters in. So we have to give it data to use. And we can't just do like we had before and pass it off until we finally decide to put some data in, but doing string name. There's no way. We actually have to give it data now because we're creating this brand new object. So let's give the name fish. Or better yet, you can go above and beyond and say fish dot class dot toString, which will give you the name of the class. I know there's an error right now because I haven't finished doing all the parameters. But essentially, this fish dot class dot toString gives you the name of the class, which is fish in this case. But just as easy, without being all fancy, you can just type fish, and we'll just keep it that way for now. The next thing is, how many legs does a fish have? 0. And is it a mammal? No, so we'll put false. So now everything is working here. We have a new fish, the name of it is fish, and it has 0 legs, and is false. Now just to spice things up, do dash, and we'll do clown. So we have a fish that is a clown with 0 legs. It is not a mammal. Now, clown, it says the local variable clown is never used. So what we'll do is we will go ahead and ignore that for right now. And we want to make a bear. So let's make a bear. We'll call it black. And we'll say new bear. But just like the fish, we have to give it parameters in here. So we'll say bear dash black. How many legs does a bear have? Of course, 4. And it is a mammal, so true. Now we have 2 different variables here. We've created 2 objects. We've created a fish object, and we've created a bear object. Both extend the animal class. So both are an animal. They both have the same methods inside them and the same data fields inside them. They also have this print data method right here that'll go ahead and print out the data that we logged as their mammal stands. This is all very confusing, but this is the mindset you have to have when you're doing object-oriented programming. You don't want to just be slanging code everywhere. You want to have organization and unity within your objects. There's a hierarchy of parent classes and child classes. The animal class is the parent class. This is the class that is holding everything together. The fish and the bear are subclasses that extend the parent class. Now, they're just basically extensions of the animal. Now our output, what we're going to do here is we're going to say clown dot print data. And what it's going to do is when it hits this line of code, it'll create our clown, it'll create our bear, and then when it's done creating our bear, we'll print out the clown data. And then just to keep things organized, we'll do system.out.print line, and we'll put just a regular old space. We'll just put some lines to separate the data here. And then we'll go ahead and we'll do black dot print data. So essentially what we're doing here, just to break down again, we're creating a fish object called clown, and we're giving it the data of the clown. We're creating a bear object called black. We're giving it basically the name and the information, the data about the bear, and then we're printing out the data about the clown. We're printing a little line to separate the two, and then we're printing out the data about the black bear. Now, essentially, say you really want to be descriptive, and you're like clown. I mean, I know it's a fish object, but that doesn't make any sense. We can just throw fish at the end. So you have clown fish, no space, just a capital F, and that is now the name of your variable, the name of your object. And now there's an error here. We have to change our references. We change the name, so now the computer says, well, there's no variable called clown. They cannot be resolved. So we need to make sure our naming conventions are correct. So clownfish, black bear, and we're ready to go. Now before we run this program, let me think here. Actually, well, let's run it and see what we got. Now that we've done all this, let's get some kind of output out of here, and then we'll go through and we'll make it even more interesting. And then I think that I'll call it quits for this video. Now we run this program. It'll give me a console. There we go. It says fish clown 0 false. It prints our line. It then says bear black 4 true. So we have our clownfish, 0 legs, not a mammal. We have our black bear, 4 legs, is a mammal. Now that's overly complicated. I mean, extremely overly complicated. It's just to get you the idea of the hierarchy of things. Essentially, we're gonna make this a little smarter now. So in our output, instead of doing all this crazy stuff, yes, we will keep our fish and our black bear here. But what we'll do is we'll say if clownfish dot is mammal. So essentially, this is an if statement right here. Within an if statement, if the condition up here is true, the code will run inside this. If not, it'll skip it. So essentially, what you're going to do here, and this makes a little sense if you read it. If clownfish is mammal, it'll run the code. But it's a little more complex than that. We can add an else statement. So if this code is not true and does not run, else is what the code is going to do. If not, if this else statement is not there, it'll just keep on rolling. But in this case, it's going to run the code instead. So it's kind of like a switch. It says, if this is true right here, if the clownfish is mammal, it returns true, it'll run the code. Now, in this case, if I said, say, let's do it this way, just to explain if statements a little bit better before I throw you guys to the dogs here. We'll do int x equals 3. And then we'll say int y equals 4. And we'll say if x is equal to, which is equal to is double equal signs, y, then we'll run the code. But x is not equal to y, it will not run this code. We can say if x is greater than y, or we can say x is less than y, and that's dealing with numbers within an if statement. And it only gets more complex. The sky has the limit. You can also do strings. I mean, we could say if name, so let's do clownfish dot name, and since we have a clownfish object, we do have access to that. Like I said, it extends animal, it has a name. Or we can use our getters, get name. Now, it's showing an error. It says it cannot convert from a string to a boolean because an if statement needs to say, is it true or is it false? So how do we get that? Well, this object right here, like I said, this has now created an object. So clownfish dot get name, like we said here, an animal, returns a string. It is a string. So this object, clownfish dot get name, is a string now. And within strings, there's a whole ton of methods. So within the string class, there's a whole ton. If you scroll this down, there's so much stuff you can use. If we say dot equals, and then we type fish dash clown. So if the name is equal to the string fish dot clown, so if they equal each other, it'll run perfectly fine. If not, it'll run the else statement. But I'm getting off on a tangent here. I'm trying not to confuse you guys, but it is very confusing once you get started. I mean, I'm not trying to overdo you as a beginner, but I am trying to really get you engaged and want to learn these things. I want to take you over the top and really show you how it gets complex. Because if you learn it complex first, then the rest is child's play, and you'll have a ton of fun creating applications. So we want to give this something better than just telling us what we put into the parameters here. We want it to actually do something. So what we'll do is we'll take these two, we'll cut them out of here. We don't need them right now. We're going to put them out here in the field of output. We'll say a public fish and a public bear. And they're just sitting out there. We can access them whenever we want. So what we'll say is if clownfish dot is mammal, back to this, we're going to go ahead and, here's another thing. It says it cannot make a static reference to the non-static field clownfish. We did not make it static. Static is very hard to explain. Static means it's always there. It's created, it's always there. If, say we had the static string for this, fish dash clown, it's kind of like, static is like an omnipresent type of object, meaning that regardless you can access it. You don't have to have it locally, it's just always there. I'll get more into it later on, but essentially, clownfish needs to be static. So we'll let Eclipse do it. We'll make it static. We might as well make bear static too. The whole reason it needs to be static is because it's being used in a static method. So a method that can be seen by programs and code other than this output class. It needs to be static so the program that's accessing it can too see these variables we're using in this code. Better practice than what I'm doing by putting this if and else statement is to go up the hierarchy of things. So we'll take this out, we'll get rid of these statics, because static is definitely, you'll realize soon that static is kind of like the plague. Once one thing is static, it all becomes static. What we'll do is we'll do a public void do stuff. Call it do stuff. So when the program starts, we're gonna do stuff. Simple as that. Now, don't tell me, yeah, do stuff has to be static. Why? Okay, so let's make this a static void. Let's make these back to static. That's not the way it works here. I keep forgetting. Essentially, once you make a larger program, you'll create this main method. It'll do something like new fish, and it'll start the code. I mean, to go off on a tangent, I'll show you the code for a video game I've been creating. Let's see. Let's open up this runtime, and we'll open up this right here. So ignore all this craziness, but essentially, here's my main method. And all that's in my main method says new ROTSB, which is this class. It creates this class and simply deploys the game. So it's kind of silly, it makes itself, but that's what I mean. This is a static method. It's kind of omnipresent in the program. So essentially, this starts this code right here. So the way it goes is the program starts, it runs this code, which in turn runs this code, which then in here runs this code, which starts this code, and it just goes from there. It's just a long, crazy, it just expands. So in this case, we're going to use a bunch of static variables so we can access this, and we can write code in here. But for now, we'll just do stuff in here. So when it runs our do stuff, it's going to run what's in here. So let's go back to this, now that my tangent is over. So if, else, we'll say if clownfish dot is mammal, so this will become true. We'll say system dot out dot println, and we'll have it say this animal is a mammal. If it's not, so if this is not true, clownfish.isMammal returns false instead of true. We will say system.out.println this is not a mammal. Now, I'm pretty sure you can tell what it's going to come up with once you run it. But let's go ahead and run it. So essentially, a quick rundown before we run it, actually, and I spoil the surprise here, which there's really no surprise, but the program is launched, it runs this code, it says do stuff. So we go here to do stuff, and whatever is within this, it doesn't. So what's going to say is we have our two fields right here. Our clownfish, that is a fish dash clown with no legs and is not a mammal. And our black bear, which is a bear black with 4 legs and is a mammal. It's going to say, it's going to ask us if our clownfish is mammal, which will give us true or false. Say in console, this is a mammal. Else, if it's not true and it's not a mammal, it's going to say this is not a mammal. So let's go ahead and run this and see what it says. It says this is not a mammal, because obviously we put false right here. It's as simple as that. I mean, you go through the hierarchy of things and it gets complex, which hopefully you understand to the best of your ability, but it is a key factor in object-oriented programming. For the sake that I taught you this first, I don't expect you to understand all this. We're going to get into really simple stuff after this. Just wanted to set object-oriented programming apart from the common misconceptions of programming. It's hard to explain. Essentially, what we've done here is we've done a huge complicated process for something very simple. Once we get into more complex stuff and we start working with GUIs and we start working with, out of the console stuff and other files, it all starts to come together. So I think I'm going to cut it off right here. Trying to think of what else I could do. I could have it before we go, let's have it compare two different things. That's a big thing. So there's different operators, and then in one lesson I will go over the operators. So let's do another if statement, and we will say if let's do it this way. Let's go ahead and get rid of this fish. Let's make actually, let's get rid of the bear and make two fishes. So public static fish, we'll call this puffer fish equals a new fish. Now we got to give it our data here, so we got to pass it our data. Fish dash, and I mean, you know what? Screw it. We'll just say puffer. I don't know why I even put the dash. I just thought it'd be cool when it prints out. So puffer and clown. And of course, fish don't have legs. And of course, it's not a mammal. So now we have something very similar. And we can compare these two things. The only difference, obviously, is the name, but we can compare these two things. So we will say if, and what we'll do is we'll use two parentheses here. We want to say if two things are similar, then run the code within here. So the way we do that is we'll put our parentheses, we'll put two and signs, which mean and. Like the logical and. Like if 1 and 1 are equal, that kind of and. And we'll put another set of parentheses, just to keep everything organized and clean, so it's readable. So we'll say clown dot fish, clownfish dot get legs is equal to 0, and we'll say clown fish, puffer fish dot get legs is equal to 0. Then we'll do system.out.println we'll say fish don't have legs. Okay, so now we're going to say here the way this works, and it's very confusing, but in the first parenthesis it says clownfish.getLegs is equal to 0. It's basically going to give you a true or false right there. It's going to say fish.getLegs is equal to 0. It's either going to say yes, it's equal to 0, or no, it's not equal to 0. Then it's going to say pufferfish.getLegs is equal to 0. It's going to say yes, true, or no, false. In this case, it's going to give us true. because the clownfish has 0 legs and the pufferfish has 0 legs. So essentially, 2 trues and this "and" will make the statement true. If this were to be false, so for example, let me just run the code really quick and explain this. So we ran our getLegs method. Oops. What? What is it doing to me? It's not running it. Hold on here. It's being wonky. Oh, it's because I took do stuff out. I'm too tired for this. See, everybody makes mistakes in programming. It's a whole load of stuff to remember and be aware of. Something as simple as like, oh, the program's not working, and it's just because I was fiddling with it and I accidentally deleted my hierarchy of things. So now we run the code. It says fish don't have legs because this was true and this was true. So both statements were true, so it became that. So the next thing to do here is say, well, we want pufferfish to have 5 legs. So in order for this to run right here, it's going to have to say fish.getLegs equals 0 has to be true, and pufferfish.getLegs equals 5 has to be true, which we know isn't true. So I run it, nothing happens. There's no output to the console. This code never ran. The way you can tell that is because it terminated here. The program has finished, it has run its course, so we know that was not true. Now what if we wanted to skip this whole "and", this logical "and", and say we don't want to have 2 trues to make it true. We just want to compare the two and be done with it, just a single true or false. So the way we could do that is the same way we did it, except we don't have to do all that craziness that I just did. We can just say clownfish dot get legs. So now we have a number is equal to pufferfish dot get legs. Isn't that a lot better? We get 2 numbers, so the leg amount of clownfish and the leg amount of pufferfish, and we compare the two to see if they're equal. If they're equal, we want to print out this, which of course prints it out. Fish don't have legs. This is getting really weird, but hopefully I'm covering it all. Like, any questions you have. If you are watching these videos, go ahead and leave the questions. I'll answer them, because I'm trying to move at a more sophisticated pace than you would your traditional tutorial. I'm trying to teach the way object-oriented programming works. Essentially, the fun stuff is what we're going to get into next video. Actually, I'm going to keep all this code. Hold on. Essentially, in the later lessons, we'll be doing stuff like actually making applications, like a calculator, and we'll eventually move away from the console. But the first thing you have to understand is how the hierarchy of things work. If you don't understand that, then there's no way to create these things. Because imagine if animal was a window on the screen, like a window on your screen, and your fish and your bear were the windows inside your screen, like the panels or components on it. You have to understand the hierarchy of things and how they all come together, like in a parent-child type way, in order for you to succeed in object-oriented programming. You have to understand how to create these methods and use them efficiently, like this print data that just printed out all the data in one row. I could have easily just condensed this all into one line of code. But I will get into the tricks and everything and the good practice in the next video. I'm thinking in the next video of toning it down a notch now that I've kind of broken you in. If you followed along or if you got frustrated and just decided to listen, it's all up to you. But I will have all this code somewhere in the near future for you to go through and pick at instead of typing it, just in case you do have an error, a typing error or something. But essentially, in the next videos, I'm going to tone it way down, and we're going to make a calculator, and it'll simply just output it on the console. It'll ask you to enter a number, enter a second number, and whether you want to add, multiply, subtract, or divide, or we'll figure it out. But that's essentially what we're going to do in the next video. I hope you guys enjoyed, tried to follow along and didn't get a little too lost. Like I said in the second lesson, I'm just trying to break you in. You don't have to understand all this right away. You just have to be able to get it down on the screen and kind of see how it works to learn how it works. So I'll see you guys in the next video. Thank you for watching.